Welcome to this Friday, well, feels like evening, so let's just call it a late Friday afternoon, I guess, live stream that I scheduled on fairly short notice to account for some pretty substantial upgrade, if you will, in the magnitude of the storm conditions that Southern California is going to see this weekend. So I did have a live stream earlier this week where I mentioned that a significant storm could be possible this weekend in Southern California. But since that time, the indications are that it's probably going to be even higher impact than I had originally anticipated. So I was able to squeeze in a Weather West blog update today and this live stream as well. And because this system will be, again, a potentially very high impact system affecting California's most densely populated corridor in and near Los Angeles County, I might also have another pop-up live stream sometime tomorrow morning or around noon. So that's TBD, depends how things evolve, but I'm guessing if I do it, that's probably when I would do it, partly because that's when the highest impact part of the storm will probably be moving through the most densely populated part of Southern California. As always, just want to mention that this channel is sponsored by Reask, a climate tech company that's helping to rethink extreme weather risk. And also to thank those who are joining, and there are a fair number of you this evening, possibly because it's late on a Friday and possibly because this is going to be quite a consequential storm for the most populated swath of California. Welcome. Thanks for being here. And also, it is really helpful for those who are interested in helping the channel to share these live streams while they are live and to subscribe and or to turn your notifications on when I do these live streams. Like today, I didn't know I was going to do one until a few hours before I scheduled this one. So thanks all for being here. Just by means of a brief overview, it has already been raining in most of California, including a lot of Southern California, over the past 48 hours. So the weekend storm will be on top of what has already fallen, which in some cases is substantial. There's already a couple of comments in the live chat pointing out that there are some places in Southern California that have seen a couple of inches of rain already before the big one moves through tomorrow. And there could be yet more rain next week. I'll talk a little bit about that as well. But over the weekend, the biggest concern is going to be flood risk in Southern California, more in some places than others, and also the chance of at least a few severe thunderstorms and even a tornadic spin-up or two. So there is a lot to talk about. I guess I'll dive right into it. I did want to offer, kind of go through this live stream in a similar way that I wrote the blog post, but with some additional detail and some morsels that you won't find there. Take a sip of water quickly because I've had 6 hours of consecutive speaking so far today, and we'll see how long this one goes. Okay, so I think what I'm going to do first is share, since there's a lot of visuals that are interesting today, so I'm going to go ahead and share that screen right away. And the first thing I want to show, this is, and you're going to see some of the things that I've just captured as screenshots or images for the blog post, but I want to talk about these in some more detail. The first is just a quick overview of where we've been recently. And where we've been recently is kind of notable because it's very different from where we're headed right now. This is not what I wanted to show here. I need to go back to my circle tool. There we go. This is a map. Take that back. I just want my line freeform. Let's just make it freeform. There we go. This is a map of the relative departure from average of temperatures over the last 15 days, so a little over 2 weeks. Across the western U.S. This is courtesy of climatetoolbox.org. And what I really wanted to emphasize here, this is a percentile map. So essentially, where you're in the blues, those would be very anomalously cold, and the dark blue would be record cold, and then the oranges are much warmer than average, with the bright red being the warmest on record, at least for this period of record through 2020. Now note that most of California is in that bright red color, as is most of Nevada and parts of Oregon, Utah, and Arizona, and New Mexico. And really the whole western U.S. is in various shades of orange and red. What that means is over the last 15 days, much of California has been at or near record warmth for a 2-week period in the first half of November. So in fact, that's a little bit cookie cutter definition, so I won't make too much out of it. But the last couple of weeks have actually been record warm in some of these places, or nearly record warm. Not in every single location in California, but especially in the mountains in the Sierra Nevada, where the snowpack is currently pretty close to zero, and also in the interior, especially the mountains and valleys of Southern California, where temperatures have been almost summer-like in the 90s in some cases. The reason I mention this is going to be very different from the weather we're seeing. So 2 or 3 weeks of record warmth and dryness. Fortuitously, though, this record warmth and dryness did not result in a particularly pronounced spate of wildfire activity, and the reason for that is because it rained a bunch in September and October. So fortunately, we actually got quite a bit of rain in most of California before we got this November heat, which pretty much negated the fire risk. In fact, it made for a really nice period for a lot of prescribed fire to occur in northern and southern California. There is one exception, though, and that is something that is worth talking about. We almost got away with it. We almost got through the rest of the year with no more destructive wildfires in California, the last one being the fires in the Central Sierra foothills in early September that burned around 100 structures from that dry lightning event. But yesterday there was a fire, and this is some footage from the Alert Camera Network shared by Neil LaRue, fellow scientist. This is from yesterday, and this is on the lee side of the Sierra Nevada, so right near the Highway 395 corridor, so on the eastern or downslope side. Before the cold front yesterday, there was a period of very strong winds that were dry winds. These were dry, downslope winds that pushed this fire that ignited. Gusts were 60, 70 miles an hour, so you can kind of see what happened. This thing blew out and was a long, skinny, wind-driven fire that burned quickly primarily through grass and brush, probably some juniper in there too in pockets, but mostly relatively fast responding fuels to dry and windy conditions in the 3 weeks preceding of near record heat. Even though it had rained here in parts of September and October, we did have multiple consecutive weeks of anomalous heat and dryness. This kind of fire has happened before on the eastern slopes of the Sierra just prior to cold frontal passages, because let me just get my drawing tool up on the screen here. What we can get is let me make this thick. Here's the Sierra Nevada. You can see the mountain slope in the image. I'm just drawing it approximately. But when you get these storms, they move up slope. You get all this cloudiness, and you get the precipitation on the windward side. All that water falls out. That air comes down this side, and it's mostly devoid of the kind of heavy moisture that you have on the leeward side. On the windward side. So on the leeward side, or the lee side, the dry side, the rain shadowed side, let's call it, what ends up happening is this air comes back down and as it does so, it descends the mountain slopes, it warms and it dries. So you can literally have rain and snow falling on the western slope as we did yesterday, and even up along the crest, but you can have fire weather conditions in the immediate downwind area thereafter. And so what you've got is essentially a recipe for a pretty unusual situation where you have precipitation occurring just a couple of miles away from where an unfortunately destructive wind-driven fire was occurring. This was known as the Pack Fire, and I'll just pop over to watch duty, as always the convenient, just to orient people. The Mono Lake, Mono County up here. Again, this is the Highway 395 corridor right along here, approximately between Bishop and the lake here. And what you can see is, if we just zoom in, this did hop over Highway 395 in the vicinity of McGee Creek. And so that's the challenge here, is that there were some structures, unfortunately, in the vicinity. There's an RV park, there's a mobile home park, and there's also the McGee Creek Lodge and some stores here. And unfortunately, the fire did blow through here. Sounds like it affected about 15-20 structures. Don't know how many of those were damaged versus destroyed. But we did have one more episode of a small community seriously damaged by wildfire when we thought we might be out of the woods for the season. So this fire is essentially, I don't know if it's out, but it's certainly managed. It's not going to cause any more problems moving forward, but that did cause some damage. And again, this is just east of Mammoth Lakes along the Highway 395 corridor. This is that small commercial airport that has flights to Mammoth. So there's that fire. It's not going to spread further from this point, but it did cause some damage yesterday. Don't want to talk too much about that, but I did think it was interesting to share, given that there was a little bit of confusion over how we could possibly have fire weather conditions given how wet it was. Well, it was dry and windy on the east side of the mountains, even as it was raining and snowing at other elevations. All right, so here's the bigger picture view. This is a live satellite view. You can see the Terminator here. The Terminator is not post-apocalyptic sci-fi in this context, but it is simply the arc of sunset that you can see sweeping across the Earth from east to west in this live satellite image. Currently, sunset is, as they say, it's reached Arizona, and it will soon be at the Colorado River. But the main point here is that there is, right now you can see pretty clearly, let me get this to stick on screen, you can see this long corridor of mid and high level cloudiness extending all the way from, south of Hawaii. So if you extend this even further, here's Hawaii over here. There isn't moisture flowing directly to California throughout this corridor, but again, an atmospheric river is a corridor of atmospheric water vapor transport. It doesn't always mean that that water molecules from location A are going to location B. But what it does mean is that between A and B, there is a corridor of transport. And what it means is often that there's convergence of the winds on either side of this that force moisture into this relatively narrow plume, and that there's constant evaporation of moisture from the water surface. There's constantly water evaporating and often precipitating or at least condensing in equilibrium. So you have up and down in this corridor of horizontal transport. And it's a bit of a messy screen. In that transport corridor, and again, here is the key atmospheric river in this case, you have water vapor that is constantly evaporating and condensing or sometimes precipitating along this axis. So an atmospheric river is fundamentally a kinetic quantity. It is water vapor moving in the atmosphere pushed by winds above your head. It isn't necessarily always going to be water molecules from Hawaii landing directly in California. It's other water that's evaporated along the path of transport. But in any case, we got an atmospheric river, and there is at least some moisture being transported from the subtropics, which the subtropics, by the way, kind of are in this band here. Once we start getting much further south than Hawaii, we start to get into the tropics. So this is almost tropical moisture down here, given that latitude. Anyway, if we zoom in a little bit on, let me get rid of my drawing tool. If we zoom in a little bit on Southern California, we can see that there's a pretty pronounced cloud deck. Right now, these clouds have more bark than bite. It's a pretty solid cloud deck, but it's mostly mid and high clouds with some embedded isolated showers. In fact, it's even sunny in western Santa Barbara County right now. And then up over, if we look up, for example, at the Bay Area, we can see that popcorn cloudiness, scattered showers, cumulus clouds popping up with the daytime heating, but mostly actually like along the coast, for example, it's actually almost clear as the sun sets this evening. But the bigger picture is this. If we zoom out, it's pretty easy to see where the low pressure system is starting to spin up. You can kind of tell just based on the spin of clouds that the low is somewhere around here, and that there's, again, cyclonic flow around this low pressure system. And it's just kind of sitting here, southwest of Point Conception, say. And it's just going to kind of linger throughout the weekend. It's only going to very slowly. It's somewhere here now. It's going to be like here tomorrow, and then maybe here by Sunday. So it's not going to make a lot of progress. It's really going to affect Southern California, especially coastal Southern California, for most of the weekend. But it's also going to affect the Southern Sierra and the Eastern California deserts. In fact, there could be some significant flash flooding in Death Valley, as well as in places like coastal Southern California. So let's get into it. What does this look like in the bigger picture? And let me zoom in a little bit on this, just for the sake of those who are on small screens. Here's another way to look at it. This is not the preferred way anymore to measure atmospheric rivers, by the way. And let me change my color since this is a little bit too close to what's on the map. This is simply the integrated water vapor, or IWV, also known as precipitable water. It doesn't actually have to do with precipitation directly, but instead it has to do with how much water vapor is in the atmosphere at an absolute scale. Is over here. It's literally in millimeters. It's essentially a question of, if you squeezed out all of the water in the column of air above your head right now, how deep would the equivalent puddle be on the ground? So the answer is literally, in this plume right here, 40 to 50 millimeters deep. But down here, look at this deep tropical moisture. We're talking more like 50 to 60. Those are very high numbers. Once you start getting up into the yellows on this color scale, that's a pretty big number for California. And indeed, there are some yellows and even some oranges off the coast. So you can see, again, this is sort of the tropical moisture plume. But where is the atmospheric river? The atmospheric river, again, is a corridor of moisture transport, not just a blob of moisture. So if we look at that, we actually get we get a similar picture, but the breadth of it is a little bit wider. So now this is integrated vapor transport, different units that aren't super important for this purpose. But the point is, we have this nice atmospheric river that's feeding into coastal Southern California, and that's pretty robust. Not extreme, but the problem is it's just going to sit here for the next 24 hours and potentially strengthen a bit. It's not going to go anywhere anytime soon. Here's 6 hours from now, it's still there. Here's 12 hours from now, and it looks like it's weakening using the IVT metric, but as I'll talk about a little bit later, that's not necessarily the best way to be thinking about this. And you can kind of see it stalls out and actually even starts to retract a bit back westward. This is 24 hours from now tomorrow. Now you see it's sort of swinging back westward and re-strengthening. Now we do have some reds on the map at the higher end of the color bar, and we can now see that this low pressure system is, as it sort of sits here, let me make this thick. This low pressure, now it's starting to bend back on itself and bring this return flow back over Southern California. So sort of bringing a ton of moisture into the catcher's mitts that are all of these concave topographic features in the transverse ranges in Southern California. So this is about 24 hours from now. This is tomorrow evening. Again, this is actually the strongest part of the atmospheric river, and it's still stuck over LA County. Finally, as we get into tomorrow night, this starts to move on and move eastward. But again, this is pretty notable, and this precipitable water plume is pretty intense as we go over Southern California. One of the things that's going on, and actually this is something that I wanted to share, so let me briefly stop sharing. You're going to see me again. There's one more thing I forgot to put up on screen. I thought it was interesting, so I want to share it with you all. Let's see. Yes, here we go. And then one more here. Make sure I've got it before I bring it back up. Yeah, here we go. Okay, so I'm going to go back to sharing my screen here. So that water vapor that I mentioned, here is what's known as a situational awareness table. It's just a fancy way of tool for meteorologists to ascertain how anomalous a given situation might be in a particular setting. And what this is telling us, effectively, is that what we're experiencing this weekend is indeed highly anomalous. So across a pretty broad area, what we have are precipitable water, so atmospheric moisture levels that are at or above the 99.5th percentile. In fact, in some cases where there's the blue, these are the highest in the observed record in these locations at that time of day. So this is a near record plume for mid-November in Southern California. Now, if we look at IVT and we add in the kinetic part of it, add in the wind piece, this becomes even more anomalous, and we actually see that this is a true record-breaking event just south of Southern California for at any time of day in November. So this really is one of the strongest IVT plumes we've ever observed at this time of year in this particular location. And all of this, again, is feeding right into Southern California. So that is pretty notable. One of the reasons for this is that we have, again, anomalously warm. We hear the word anomaly, anomaly, anomaly. Well, this year is in so many ways an anomaly. I've got to toggle between color bars here. Hot pink sounds good. Again, I've shown this map a lot, so I won't linger, but we have a really broad region of really warm near-shore ocean water near California. So we can see, I'm cutting off the color scale here. Here we go. Again, so we see this, and then we see sort of where we are on the color bar. This is sort of between 1.5 and 3 degrees centigrade, so multiply by 1.8, and we have water temperatures that are 2 to 5 degrees Fahrenheit above average, and that might not sound like a lot, but given how broad of a region this is, extending all the way back, in fact, it's even warmer once we get to the Central Pacific, think about where the atmospheric river that I just showed you is oriented. The atmospheric river is essentially doing this, funneling into Southern California. So it's traversing a long stretch of that much warmer than average water. So the atmospheric river probably has a good 10 or 20% more water vapor than it would otherwise. And that doesn't just raise the ceiling on the precipitation intensity by 10 or 20%, but potentially some more. So some broader climate and oceanographic context today. Let's see. I got so many things open. I'm getting a little bit confused here. Okay, so where are we now? Well, let's actually take a look at. Let's take a look at. Well, let's see. So I actually ended up. You'll see my face again. I gotta toggle back. I'm missing a tab here because there's so many tabs open. By the way, folks will be pleased to know that I had another encounter with the squirrels that really love to eat the internet cables today. I was able to get Comcast to come out on pretty short notice, and our upload internet speed increased by a factor of 20 right after they replaced once again the squirrel-chewed cable. It seems like they're having to come back every 6 months. Squirrels really don't want me to live stream, but it looks like it's doing well now, and I'm glad they were able to wrap that work up today before this live stream began. Okay, so enough complaining about small mammals and their chewing proclivities. Here's what I really wanted to show. All right, so back to what I often show on these live streams, so the Tropical Tidbits website. And after all that, actually, I think what I'd like to do is not, in fact, show Tropical Tidbits. What I'd like to do is show a different website that I also think has really good weather information. All right, so this is actually Pivotal Weather, and I like to give these websites credit because there's a lot of work that goes into assimilating and plotting this kind of real-time imagery. If others didn't do it, we wouldn't get to see it because I certainly don't have the time to do it myself. Okay, so this is a current plot. Let's go to right now. Yeah, this is now essentially right now. This is a plot of dew point temperatures over California, and this, again, dew point temperature actually isn't a measure of temperature, but it's somewhat misleadingly a measure of moisture. It's the temperature at which dew or condensation would form. So what is this telling us? This is telling us that in the blue region down here, that's a wedge of really moist air by California standards. In fact, if I toggle over this, you'll see dew points temperatures near the surface in the 63, 64, 65 degrees Fahrenheit. That's really muggy, moist air. Even in Northern California, these are relatively high. But in coastal Southern California and what's known as the bight, the Southern California bight, this is a juicy air mass. And we see that this juicy air mass is sort of converging at a point. So there's sort of this line here where the dew point's less, where the winds are coming from this direction. We also have really moist air from here that's coming sort of from the southeast. So there's this convergence line that's forming right around here. It's a little bit subtle right now, but I'll show why this is important in a little bit, because I'm going to show a quantity that I don't usually show because it's usually not relevant in California, but it is right now. This will be really interesting for the true weather geeks out there, but this is the quantity known as theta E. This is actually called equivalent potential temperature. Meteorologists like to give really complicated names to certain things. It turns out there's a good reason for this one, but equivalent potential temperature, theta E, is essentially a measure of the total heat energy in the air at a given point, at a given location, at a given time. So it's essentially a measure that incorporates both the temperature of the air and the moisture content of this air together in a single quantity. And the reason why it's important is it kind of tells us a little bit about the total, the level of energy or the potential energetics of storm systems in a given environment. And the higher the theta E, the higher you go up the chart, the more potential energy essentially they can be released in certain kinds of storms. And kind of a benchmark for significant numbers are really, you get above about 320 here. You can kind of see this color bar really emphasizes everything below 320 is kind of a literally beige color, and everything above 320 starts to be a little bit more interesting. So look at what we got over this coastal region over Southern California. You can kind of ignore this. That's the Gulf of California where the water's really warm. It's not super important, but well, it's important, but it's this quantity isn't always the most useful in that context. But if I toggle forward in time, so look at what happens as we go into the weekend. We start to see that theta E starts to increase again. In fact, we go well above 320. We get around closer to 330, 328. And also, the other thing I want to point out is that we start to see this narrow band of convergence. So essentially, we have winds coming from this direction over here on this side of the boundary, and we have winds coming from this direction and from this direction. So what do we have here but a theta E boundary where there's pretty low theta E on this side, side A, and there's rather high theta E, equivalent potential energy to the east. So the point really here is that this is an unusually energetic air mass because it is not just moist, but it is also warm. And those two things together, especially when there's a gradient in this quantity. So here it's really high, here it's pretty low. This boundary will serve as a catalyst for some interesting weather and potentially some severe thunderstorms and very heavy downpours later on, tonight into tomorrow. As we go forward, this is the early morning hours. You can see this boundary kind of stalls out over LA County and just offshore of San Diego as we get into, in this case, this is looking more like the early morning hours tomorrow. And then before it moves eastward, although you can kind of see this boundary continues into the deserts of southern and eastern California, and there could be some flash flooding and severe thunderstorms over here as well. Okay, so what else is interesting here? Well, if I show, let's see what I can show here. So here's the composite reflectivity. So this is essentially a simulation of what the radar might look like. Where are we now? So it is about, this is about now in Southern California, and this looks about right, where there's some scattered showers, nothing too impressive. You can kind of see these high, thin clouds. This is mostly virga or precipitation that's evaporating before reaching the ground. No big deal. But we go into the overnight hours and we see the first kind of convective blowout. These might be showers or thunderstorms, mostly west of LA County. So this would be more Santa Barbara, Ventura counties earlier in the overnight hours. And then as we get past midnight into the early morning hours, we see more activity starting to show up in the Southern California Bight. So along and offshore of LA County, Orange County, San Diego counties. And then as we get into tomorrow, in the early morning hours, that's when things really start to get active over LA. And look at this big blob that starts to move into some of the most highly populated corridor in Southern California. So this is when the brunt of the storm is going to come through. This is the early morning hours tomorrow, maybe around 6, 7, 8, 9 a.m. Pacific time. And a lot of it's going to linger for a couple more hours, potentially until about around noon. A little bit later, as down San Diego, the peak might actually be noon or a little bit later. The other thing that we see is that there is this pretty intense arc of heavy downpours and thunderstorms that moves inland across the deserts in the southern Sierra. So there is, again, as I mentioned, in addition to LA County, which I'm going to talk more about in a minute, a real risk of flooding in the deserts, as well as maybe some severe thunderstorms. Now, behind this, there could be some isolated, pretty strong thunderstorms once again into the early evening hours across all of coastal Southern California. So the sun may come out in the early afternoon, but you don't be too surprised if you get another strong thunderstorm or two on a more isolated basis into tomorrow evening. That could very much be the case into tomorrow night before the storm system moves on and we talk about the next one to come. In terms of thunderstorms, what's interesting is that the CAPE, or the convective available potential energy, which is a common metric to measure the level of atmospheric instability, it isn't crazily high, although actually, now that I'm pulling this up on the new model, that is fairly high for coastal Southern California. So this would be, let's see, this is just later this evening. LA County getting close to, so that's getting over 1,000 joules per kilogram. So actually, I take that back. Although it's not super high everywhere, it's more like 200 or 300 joules per kilogram. Once we get toward LA County, that's closer to 1,000, and that's a pretty decent number. So that first wave of instability, thunderstorms possible already in the overnight hours tonight, and then this continues, and you see another slug coming through closer to the morning. So this is now getting toward 2, 3 a.m., and then yet another window of instability as we get into the late afternoon tomorrow. So multiple waves of some convective energy in Southern California that I actually think might be underselling the story a bit, because it's not just a case of how much convective energy is available. That's part of it, but it's also a question of how unstable is the air mass overall. So we have this question of is the temperature profile favorable for convection? And here is where I think the interesting stuff starts to pop up. Remember that theta E boundary, that dew point boundary? Well, look at where the most unstable air is. It's right along that kind of axis right here. And so this is later this evening. Watch what happens as we go into tomorrow. Okay, well then this is some pretty unstable air as we get into the early morning hours, starting to set up again right where that boundary is, immediately offshore of Southern California. This is when we might see some severe thunderstorms start to pop up in the overnight hours. Could be some water spouts or even a brief tornadic spin up into the morning hours before this moves inland over coastal Southern California, and then there's another round later in the afternoon. So there is some potential, and this may not be necessarily the best model to show it. So let's look at another model. This is the HRRR, or the HRRR, looking at the lifted index again. It's showing something similar for this going later this evening, and then another round later tomorrow. Let's look at the instability here again with the HRRR, just to see, since I'm just curious how this is updated. Again, showing notable, not extreme, but certainly sufficient in this super moist environment, atmospheric instability to produce some thunderstorm activity that could even locally cause a water spout or a tornado or two. And the most recent area forecast discussion from the National Weather Service in Oxnard, which serves the LA area, is really interesting in that regard. So I always, weather nerds and anyone else who cares about the details, do check out that area forecast discussion from the Weather Service. What does the actual amount of rain look like potentially? Well, if we look at the total for the storm through the weekend, again, the totals don't look particularly extreme. These are definitely notable for November in coastal Southern California. So LA proper could easily see 2 to 4 inches of rain by Sunday. That's a lot for LA in November. fact, it might make for one of the wettest November storms on record in LA. But these are not earth-shattering totals in a broader sense, but there's quite a broad region that might see at least a couple inches of rain this weekend. I mean, that includes most of California's most densely populated areas and a decent chunk of its quite arid desert as well. But the bigger problem will probably be the fact that in the mountains, this could be considerably higher, and I think this model is, this is the European ensemble, so it's kind of potentially underselling things a bit. Let's look at the non-ensemble, the actual operational model. So this is the higher resolution version of the very same model there, and you can see that the peaks start getting higher. We start seeing more like 5 and 6 inch totals in some parts of LA County, including a couple close to the coast. So LA could definitely see some 4-inch totals. And here, it's becoming a little clearer that there's going to be a narrow axis that sees a lot more rain than elsewhere. So kind of along this axis here, which is squarely centered again on LA County. So this is going to affect quite a few millions of people into tomorrow. And so the greatest flash flood risk really is going to be focused on some pretty densely populated parts of Southern California. And if we look at an even higher resolution model, what you'll start to see, and this is pretty typical, is that if we look at something like the 3-kilometer North American model, we see that, again, some of these very isolated high mountain peaks are seeing quite a bit more. We see more like 6 inches or 7 inches or 8 inches. So I don't think LA is very likely to see 8 inches of rain, but could there be parts of LA County in the mountains that see 7 or 8 inches of rain this weekend? Definitely. The mountains of Ventura County, up above Ojai, places like that. But what's notable is that LA City proper could well see multiple inches, as could San Diego, and that's a big storm for those parts. The bigger issue, though, is what might fall over a shorter period of time. So how much water per hour? And the answer is a lot of this rain could fall in just 1 or 2 hours. And that's the reason why we're concerned about flash flooding and debris flows. It's not so much the total amount. We've seen that before many times, of course. But the problem is we might see an inch of rain in some cases, or even more than an inch in an hour. And that's the kind of rainfall rate that can cause big problems in Southern California, where we have steep topography, where we have recent wildfire burn areas, many of which will be highly susceptible to debris flows and canyons. I would be very surprised if there were not significant debris flows and flash flooding along the Pacific Coast Highway, Topanga, Malibu, and into the Pacific Palisades area, where there were multiple fires in late 2024 and early 2025. There could be some again near Altadena with the Eaton fire, but the bigger concern, just based on the vulnerability, is probably Pacific Coast Highway. There could be some major urban flooding, so street freeway flooding, streets and creeks in places that don't normally flood could see some flooding in LA County. And again, part of the impact from this isn't because we expect an extreme flood, but we expect some notable flood risk in a place that's home to many millions of people where it doesn't flood that often. And so that is one of the reasons why the potential consequences are notable. The other thing, too, is to note that, again, the absolute numbers are much lower. Let me change the color here. Are much lower out in the deserts, but keep in mind that some of this area in yellow is the driest part of California. Death Valley is in here, and this part of the state is slated to see several inches of rainfall this weekend. That's not that much. That's essentially equivalent to what in some years is the total annual average rainfall in a day or two. And in many cases, that might fall, again, as I mentioned, in an hour or two. So significant flooding, especially in this part of the desert, in the Basin Range part of eastern California. Other risk in coastal Southern California that won't be as extreme, but it will certainly affect a lot more people. And there is that risk of potentially some isolated severe thunderstorms. And where do I think that is most likely? It's not officially in the Storms Prediction Center outlook yet, but stay tuned. It might be, I think, kind of in this swath. If we're going to see any severe thunderstorms, I would expect it to sort of occur in this region. And again, that's probably, if I drew a most populated swath in California, that might be it. So that's what might transpire this weekend. All right, let me think if I have any other data I really wanted to show. Nope, I think I'm going to shift back over. You're going to see me back full screen, and it's time to take some questions after I drink some desperately needed water here. So a lot of new and returning visitors today. So thank you. And again, just to remind folks, I probably will be having a second live stream at a to be determined time tomorrow morning, sometime between 8 a.m. and noon, probably closer to late morning when people are awake and when the storm is peaking. So we'll see. Okay, so let's get to some of the questions here. Looks like the data quality has been good during this stream, so it looks like Comcast successfully vanquished the squirrels. Well, actually, they didn't do anything to the squirrels. They replaced the cabling. Hopefully the squirrels either will decide to stop chomping on it, or they will. It will take them a while to gnaw through the new cable, and I'll just go through this song and dance again in 6 months. Anyway, all right. Let's see here. Roger mentions 2.1 inches already in Ojai. You'll probably more than double that total before all is said and done, and in the mountains could easily triple it. All right. This is the challenge. Sometimes when there's comments from earlier in the live stream, I have to quickly review them and sort of figure out what I've already answered, which is a fair number of them. It's a question from Damo. Is this how the arc storm starts? Well, the good news is almost certainly no. We would need a much more prolonged period of highly anomalously wet conditions. And although it does look like the wet pattern is going to continue into next week, and there could be an additional heavy rain event in Southern California, it does look like things are going to start to dry out by the end of November. So now things can always change, and there is a bit of a wild card. We are going to experience what is known as a stratospheric sudden warming event, or sudden stratospheric warming event, SSW. What this effectively means is that there could be a perturbation to what is known as the polar vortex. I realize I'm introducing a lot of fairly esoteric meteorological terms here. The polar vortex is not, in fact, a news media creation of the 21st century, but is actually something that does exist. Now, the difference is in the real meteorological version of polar vortex, this is not some anomalous feature that suddenly invades a region. It is, in fact, something that is almost always present. The polar vortex is a characteristic feature of Earth climate that exists, as you might expect, in the Arctic, spinning in the upper atmosphere. Think of it kind of like a fence of strong winds that holds cold air in the Arctic. And when that fence, when the jet stream starts to weaken, or the fence buckles a bit and you get these latitudinal loops, some of that cold air can spill out. Well, that becomes more likely when you have something that's known as a sudden stratospheric warming event. So essentially when there is a rather discontinuous warming of the stratosphere, which is the higher than the troposphere where most of our weather occurs, that occurs very high, starts to affect things at lower levels, including the tropospheric polar vortex. And once a sudden stratospheric warming event happens, it can disrupt that fence that's holding the cold air in the Arctic. And what can happen is you actually have displacement of air from the Arctic. You get lots of high pressure in the Arctic and low pressure in the mid-latitudes. Of course, we live in the mid-latitudes in the western U.S., not on the Arctic. So you tend to get weather patterns that are characterized by these very loopy jet streams. And that tends to be a pattern that can result in weather patterns that get stuck in place. So these persistent weather patterns. Right now, we're stuck in a little bit of a persistent wet pattern in parts of California. Hasn't been going on that long, but it's going to last at least another week. There's a persistent ridge over the North Pacific, Gulf of Alaska, and a persistent trough to our east, or over California right now, and then a ridge again in the eastern U.S. with a big honkin' high-pressure system over Greenland. That high-pressure system over Greenland is going to stick around, and that ridge over the Gulf of Alaska is going to stick around But the position of that ridge is going to shift a bit, and it looks like it's going to shift enough to the east to start making California drier later in November and early December. That might shut the spigot off. That's not what we would see with a prolonged flood scenario. But there's always a slight chance that that ridge stays a little bit further west than initially anticipated and then results in a more persistent wet period than is currently being anticipated. So the short answer is no, there's no indication of a very wet period for a prolonged period to come. In fact, starting in about a week, it looks like northern and central California might have a somewhat drier than average period for a couple of weeks thereafter. So the risk right now is much more the short term in terms of flood. There's some comments about the fire in the Eastern Sierra, and even though it might only be officially 5% contained, the agencies are usually pretty conservative in listing containment, and it can essentially be almost extinguished, a fire of this size, under rainy conditions. And even though if the containment's only 5%, this one would be very unlikely to flare up. So it's likely its final footprint has already burned, even though the containment is officially still only 5%. This is not like a 200,000 acre fire burning in the middle of summer in the remote mountains. This is a bit of a different situation. So a number of folks asking about tornadoes, and as I did mention, there is a chance of some what would be known as low-topped supercells or mini supercells, which is something that's a bit different from their gigantic, much taller, much more powerful Great Plains severe thunderstorm counterparts. But they do occasionally occur in California. There is a mini tornado alley, by the way, in Los Angeles County, and this is the kind of pattern where you could see a tornado or two spin up in that somewhat subtle California tornado alley. And LA County does look like to be the epicenter of the rotational component of motion of some of these little supercells that might spin up. Supercell, by the way, is just a name for a thunderstorm that has a prolonged lifespan because its updraft is sufficiently separated from its downdraft that you don't have cold rain falling into the warm updraft. And so essentially the storm doesn't kill itself off. So they have some staying power, and they usually do so by rotating like a barber along a vertical axis. Think of like the barber pole rotating. So when thunderstorms have that kind of rotation, they can sustain themselves for longer, they can get a bit stronger, and by virtue of having that rotation, they tend to be somewhat more likely to produce rotating wind phenomena like tornadoes and waterspouts. So won't be widespread, but there is a possibility tonight into tomorrow of an isolated tornado or two in Southern California. That is possible. Nothing going on right now, though. And again, keep in mind, for those who are a little less familiar with the meteorological terminology, tornadoes are very small in scale. There can be a tornado that's only 30 or 40 feet across. They can be very small scale. The very largest tornadoes ever observed, and this is at the extreme upper end, are a mile or so wide. So tornadoes are very small relative to other wind phenomena. They're not something that persist. They can persist for a long time, but they're very small in spatial scale. So even if there were multiple tornadoes in a given region, something like 99.5% of the area experiences no tornadoes, even during a legitimate tornado outbreak. And again, I'm not necessarily saying there's going to be a tornado outbreak in California with this event. That appears unlikely, but there could be a couple. But keep in mind that the impact outside of a very narrow area would be low or zero. But, if your house is in the path of even a relatively weak tornado, that can still cause some big problems for you or your neighborhood. So there is a record. We've seen a number of fairly damaging tornadoes in the LA basin and other parts of coastal Southern California in similar patterns in the past, including in the last few years on multiple occasions. So, it's an isolated threat, but it's a notable one if it happens to materialize right where you live. There's a comment that individual model runs are showing a 10-inch storm for parts of Southern California last week. European model showing the same thing last night. Well, just to be clear, it's not showing a 10-inch storm individually. It's showing 10 inches of rain over the next week. So that would be the combination of this weekend's significant high confidence storm and then another subsequent pair of storms later next week, which are much lower confidence. But just to be really clear, these are still extreme outlier solutions, even in the broader model ensemble. So each weather model is run dozens and dozens of times during each update cycle. And what a lot of people are focusing on are the very first member, the single member of each run, rather than the dozens of other members that show much less extreme rainfall. So is it impossible that there could be 10 inches of rain in LA this week? No, it's not impossible. I would put the odds somewhere between 2 and 5%. So wouldn't bet on it. And it also wouldn't occur in one storm. That would be a very different story if there were a legitimate risk of LA City proper seeing 10 inches of rain with this single storm. Fortunately, that just does not appear to be in the cards. There's a very slight chance that there could be something close to 10 inches of rain over the next week or so. More likely, we get closer to 4 or 5 inches over the next week, which is still a whole heck of a lot of rain for November, and in fact, will almost certainly bring one of the 3 wettest Novembers on record to much of Southern California and LA specifically, and potentially, if we do end up on the wetter side later next week, possibly the singularly wettest November on record. So that would be quite something. But 10 inches is very much at the outer edge of what's plausible. So there's some further comments about the tornado potential tomorrow. And again, the potential is modest, but it is there. Talking about storm shelters. And it's true that in California you don't tend to have basements in most buildings like you would in a classic tornado alley or other sorts of storm cellar type features in buildings. But the reason is the kinds of tornadoes that occur in this part of the world, generally speaking, are much weaker than their tornado alley counterparts. That's not true 100% of the time, but it is true something like 95 or 99% of the time. So a tornado in California would most likely be an EF0 or EF1 on a scale of 0 to 5. So essentially the 2 lowest ranked wind speeds on a 6-point scale. And those might be wind speeds up to around 120 or 130 miles an hour or so. I don't remember the exact cutoff for EF1. But the point is, those are definitely damaging winds if they happen to hit your house. But they're not the kind of winds that would send a car airborne. They're not the kind of winds that would level well-constructed buildings. In the Midwest and in Tornado Alley in the central U.S., you can have tornadoes that have winds of 200, 250, sometimes in the most extreme events, 300 miles an hour. Now think about that for a minute. 300 mile an hour winds makes a 100 mile an hour wind not sound so bad, especially when you realize that the damage and the force of the wind is a nonlinear function of speed. So a 300 mile an hour wind in a tornado is not 3 times worse than a 100 mile an hour wind, but is in fact many, many times worse. So this is not to freak people out about tornadoes, but it's instead to say that the reason we don't have storm shelters is A, tornadoes are generally rare in any given location. They're certainly not extremely rare, but in any given city, they're in California, say they're quite rare compared to the central U.S. where they're much less so. But more importantly, if you do get a tornado, you're not going to get a 200 mile an hour tornado in California. You just don't have the right ambient environmental conditions to produce them. If you do get one, it will be something more like at the lower end of the scale. In which case, the best advice typically is the same advice that you might use in any other major windstorm, which is to stay away from windows, If you're outdoors, get away from power lines that can fall, or trees that could fall over, or branches that could fall on you. And if you're in a structure, just stay away from windows. And if it gets really bad, you can always retreat to an interior room. Bathrooms, especially interior ones, are always good. But the reality is, in almost all circumstances, you're going to be okay even if you don't do those things in California. But it's always prudent to do so. And the Weather Service does try to issue severe thunderstorm warnings or tornado warnings minutes before this would occur, so you have some advance notice. Sometimes it's hard to do that for these mini supercells in California because they're not as strong. They don't have as characteristic of a radar signature as a really violent, enormous tornado might over the central U.S. Those are a little bit harder to miss. But generally speaking, if you're under a tornado warning, it is a good idea to do those things, to stay away from windows, stay away from power lines if you're outdoors, get away from windows or things that can fall over. And if you want to, an interior room is usually the safest place in whatever building you happen to be in. And so, again, I think that it's very unlikely that very many people will have to manage that kind of risk either tomorrow or in other similar storms, but it's possible. So it's good advice nonetheless, but mostly looking to reassure folks rather than scare people off there. All right, here, just continuing to go through these comments and take a look as we get close to the hour. Comments are coming in a little fast and furious as the hour goes on, so I'm just working on this to see. All right, I've made it 2/3 of the way through. Home territory now. Jerry does mention that, and this is probably one of the most significant tornado events in Southern California, modern Southern California history, would be the 1983 Los Angeles tornado, which was an F2, which is sort of more middle of the scale. It's not low end of the scale, and there was extensive damage. There have been other more recent ones. But again, this is a little bit of an edge case. Tomorrow is one of those days where we get a little bit closer to the edge cases. But again, it's something more to be aware of than to be highly worried about. And again, those kinds of measures I just mentioned are what would usually keep you safe in almost any foreseeable tornado scenario. In California, anyway. If you're in the central U.S., you might need, and you're there during a tornado season, you might need to be a bit more circumspect about your risk. But in California, it's a bit of a different story. A story of less risk, to be clear. Seems like the strongest rain in LA should be late overnight and the early morning. Yes, I would agree with that, generally speaking. This question from Jerry. I live near the LA River in Studio City, and it almost topped during the 22 and 23 storms. Any chance we can see that again? It's unlikely with this event. It's difficult to say that it's impossible because, when you have a heavy rainfall event in LA County, the LA River is draining some very steep mountains, essentially. So the drainages for the LA River are ultimately... So if you get a stalled thunderstorm, for example, in the watershed above the LA River, then I would never say never. But generally speaking, the LA River is well managed flood-wise. for floods up to a pretty extreme magnitude. Now, I'm not sure I agree with some local officials and Army Corps folks who have told me that, quote, the LA River can never flood again. That always seems a little bit like tempting fate, and from a person who studies, from the perspective of a weather and climate scientist who studies the very most extreme rain events that California can get, I don't think that's true in a general sense, but it is true that it would take a highly extreme event to produce that, and I just don't think, mainly because we don't have enough persistence of the storm. If we had tomorrow's storm, but it was going to last 3 or 4 days, it might be a different story. I think it's pretty unlikely tomorrow, but I can never say 0% chance because there is the potential for some really heavy downpours getting stuck over the mountains for a few hours. But the bigger risk is actually not the LA River, not the bigger rivers in Southern California, but the smaller streams and creeks and washes, the normally dry stuff, as well as canyons. The canyons, the recent wildfire burn areas, that's the main epicenter of risk for debris flows and flash floods. And also just places in the city that don't drain well, roads that have low points, clogged drains, storm sewers that are not up to our warmer 21st century standards. Those are the kinds of places that we be most likely to flood as well in a situation like this. A lot of comments about the squirrels. No, those were not the only reasons why I was frenetically trying to get stuff done this week. It sort of emerged on top of everything else that's going on. So it's been, let's just say, a very long week, and next week is going to be a very long week again as well. What is the wind aspect in SD? I'm guessing San Diego over the next few days, asks EKC Civic Dude. Well, for now, mostly south and southeast, and they could get pretty strong later tomorrow. So kind of typical pre-cold frontal wind direction, and then they will shift after the cold front and be more from the west. So winds from the south, southeast, and they could be pretty strong by tomorrow. This is not going to be a big storm for Northern California, by the way. There will be some wraparound rain on the north side of the low, but this will not be really any flood or significant thunderstorm risk up north. So this is more just sort of a rainy weekend type scenario. Nothing too dramatic up north. This is squarely, in terms of risk, a Southern California event. There's a comment from Big Clutch that I think the November 14th through 18th, 1965 event may remain in the record in many respects. It probably also holds the record for IVT and IWV. We were talking about that earlier. In the area south of Southern California, presumably over the Pacific there, but we'll probably never know. Well, it is true that the data set I was using does not have data going back that far, so it wouldn't be reflected there. However, there are reanalysis data sets that go back into the 1960s. So this is an answerable scientific question to a reasonable degree of certainty. I haven't done that, so it's certainly possible. But that is actually something that somebody could crunch the numbers on, for example. Those data do exist. It's a question about the MJO, meaning the Madden-Julian oscillation, and it's something that I unfortunately don't have the time to get into this evening. Perhaps another time. Question is, fire season over in Southern California this year? Well, it probably will be once this rain moves through this weekend. I think that's pretty fair to say. So unless something pops up in the next few hours and it's already starting to rain in some places, then I think we'll be in good shape. Well, since Eric mentions to my comment earlier that the most recent GFS is just one run, that it is in fact showing 10 inches from a single storm later next week, let me just take a look. I'm just curious. I'll take a look in the background while you still see my face. You'll see my shocked expression if that in fact. Oh man, I see what you mean. Well, that is quite something. That is exceptionally unlikely to materialize. However, exceptionally unlikely does not mean impossible. So I will say that if a storm like the GFS is showing for, and this would be like next Friday into Saturday, so about a week from now, were to materialize, and the flood threat with that one would be considerably greater than with this one because of the cumulative effect. Now again, it's very unlikely to play out that way. I don't think it will, but just to crunch the numbers, yeah, I can see why that was mentioned as potentially a blockbuster event. So again, obviously, if that happens, I'll be spending a decent chunk of time next week talking about it. So it won't go unmentioned. Right now, it's highly unlikely. But thank you for that clarification. You are right. There's a quick question about the stratospheric warming, the polar vortex stuff. I know it's a lot. I can talk more about it next time. How long will it last? A dry period following a wet period at the end of December if La Nina collapses quickly. We can talk about a little bit about that more next time. But in general, the seasonal outlooks from the seasonal model still depict Central and Southern California as most likely having a drier than average winter. Not by really strong odds, but it would be interesting if we had a really wet November and then the tap shut off. It wouldn't be the first time that had happened. The consequences would be less than if it hadn't rained in November, and I'm not totally convinced that'll happen, but it's certainly possible because the seasonal cycle does mean that different influences are important in the autumn versus the winter. So it's very possible for something that produces a very wet November to lead to something very different as we get into later December, January, February. So I'll talk a little bit more about that next time. All right, I know there's a few folks who just joined at the end of the hour, and I'm about to wrap up, but this has been recorded, as all these sessions have been, and if you missed it, as soon as I push stop, you can go back and watch it again. The live version is permanently archived, as are all of my live streams, so you can go and review it and check out the auto transcript if you want to search for something specific. That goes for the journalists in the audience as well. I don't know how many of you are on here on a Friday evening, but you never know. All right, stay safe out there. And as I mentioned, there's a decent chance I'm going to pop up at some point for a quick little live stream tomorrow morning when the peak of the storm is moving through LA County, talking about flood risk and if there are any, some severe thunderstorms and the potential for a tornado or two. So stay tuned for that. If you want to be notified when that happens, you can subscribe to the channel, turn your notifications on, and or you can follow me on social media and various platforms. I'm probably there, and I usually announce these sessions as soon as I've scheduled them over there as well. So thanks for your attention. Enjoy your Friday night, and if you do see some flooding tomorrow, stay safe out there. People underestimate it, but people worry about the thunderstorms, people worry about the isolated tornado risk, but what the real risk to people would most likely be are those that flooding and those debris flows if and when they occur. That's the kind of thing that really does threaten people's lives in California most often when it comes to severe weather. So stay safe out there and maybe